The broadcast is now starting. All attendees are in listen-only mode.
All right, welcome everybody. Thank you for coming to our webinar on embedded AI for banks and credit unions. We're so glad that you're taking some time out of your day to join us. My name is Sean Helwig. I'm with Pomerol Partners. And before we get started, I'm just going to do a couple of quick housekeeping items. Number one, for those of you who are asking or might ask, the session is being recorded, and we're ecstatic to have you share the recording with others. We'll send an email out later. We should have it ready to go by the end of the day. The second housekeeping item is that we have all the participants on mute right now, just so that you're aware of that. And then the third is that if time permits today, we will save a little bit of time for questions at the end, or we'll do our best. If not, because we are going to go through 4 individual demos today. So if we don't have time, feel free to just send us an email. We'd be happy to follow back up with you and respond to those questions that way as well. All right, you can go to the next slide, Dom. Okay, all right. So the objective that we wanted to cover today is to help kind of clear the mist or clear the smoke that's out there around how to really use analytics in an advanced way, or data science, if you will, to help solve some really real-world business cases that are there for banks and credit unions. There's all this hype in the news about AI, machine learning, all these other things, and what we have found in talking to our clients is that there's just a lot of confusion about how you actually do this. So the purpose of today's webinar is to really take you through 4 different demos, kind of call them vignettes, if you will, that are specifically designed to kind of clear that smoke away and show you exactly how you can use your data in an advanced way to make better decisions, and through today, some more proactive decisions. So as we go through the 4 demos today, there's really 2 key themes that I want you to be thinking about, or to make you aware of. The first is transparency. We're going to tell you exactly how to do the things that we're doing in these demos. Okay, we'll tell you which data sources are involved. We'll even go so far as to give you kind of a gauge as to the level of effort involved to make these things happen, as well as some ballpark budgeting so that you understand just what kind of an investment's involved in trying to achieve these types of kind of statistical analyses that we go through. So that's theme number 1. The second theme that you're going to see is that we're using Click as an underlying platform to enable all 4 of the demos. Okay, and we'll tell you a little bit more about Click as an analytics platform in just a second as we do a basic intro, but just be mindful that that platform enables us to do all kinds of fantastic analytics and work with the data, and you'll see that as we step through each of the demos today. So that's our agenda. The first demo, we're going to go through how to identify successful offers for specific customers. Essentially, statistically, which offers are most likely to be accepted by your existing customer base. Second demo is going to be about predicting customer churn, identifying again which customers are most likely to leave. The third, we're going to look at how to predict loan risk to see which loans are likely to not be fulfilled by by the loan holder. And then the fourth, we're going to go and do some geospatial analysis with Click to identify optimal branch locations, so that you can kind of see where might be the best place to put a new branch location or where to move a branch location. Okay, you can move on. All right, so our presenters today. So again, my name's Sean Helwig. I'm a director with Pomerol Partners. I'll be more your moderator, or maybe your MC, if you will. And then Dom and Owen are both consultants with Pomerol based in Chicago, and they're going to be kind of at the helm working us through the demos, and then I'll provide a little bit of color commentary as we go through it. So very briefly, who's Pomerol Partners? Quite simply, Pomerol Partners is an analytics and data science consulting firm. We've been around since 2013. We were founded over in London as a spinoff out of Deutsche Bank. And then in 2017, we opened operations here in the United States and have been growing ever since. And we're now with over 50 consultants around the world and a growing portfolio of clients that have just been an absolute blast to work with. So we're really excited about where things are going. As it relates to financial services clients, again, being spun off out of Deutsche Bank, there's obviously a lot of kind of core financial services experience that exists within Pomerol Partners. But here in the U.S., this is just a few of the clients that we work with here. And you've got some really big names, multinational corporations that have highly complex needs and highly complex solutions. And then we also work with regional and local credit unions and banks as well. And so there's the point here is we work with a whole variety of different clients with a whole variety of different requirements. And one of the great things that we can do as a firm is we can work with you individually to craft a solution that meets your specific needs at specific price points that are appropriate for you and the budgets that you have available. So say large or small, we have the ability to tailor our solutions to meet those needs. And then briefly about Click, this sentence kind of says it all. Click is really the only end-to-end data integration and analytics platform in the world, especially in the world that's not owned by some multinational conglomerated company like a Google, or IBM. Click has the ability to take your data from raw source, pull it in, move it, organize it, give you the mechanisms to store it and catalog it, and then present it back out for all kinds of types of analysis. So we're going to see things primarily on, I'll say, the right end of that spectrum today, where we're doing the advanced analytics on the data, but Click enables the entire platform from start to finish. Okay, all right, so that's it for intros. We're at less than 10 minutes, so I'm off to a great start. So pat myself on the back. At this point, we're going to jump into each of the 4 demos. And with this one, I'm going to hand the reins over to Dom. And Dom's going to take us through this demonstration again on how to identify these successful customer offers. Okay. Again, in that spirit or vein of transparency, what we're using today is we're going to start using just Click as a basic, Click Sense Enterprise. There's a feature called the Click Advanced Analytics Toolkit. It's free, plugs right into Click. It enables integration out to R and a whole host of other embedded analytics capabilities. We are going to be pushing some data out to R and then returning the data set back. So you'll see how that works. The way each one of these demos will say the level of client expertise that's required. This is pretty basic. There's not a, you don't need a data scientist on board in order to execute this type of analysis. It's a very basic software investment. In fact, I'll be so transparent as to say you can get started with this as you're seeing it today for as little as $5,000. So we're not talking about $1 million budget to do this type of analytics work. And even the professional services to help you get going is very light. It's not like you have to engage in a 6-figure project for us to come in and help get this set up for you. So it's pretty straightforward. So that's kind of the kickoff for it. Dom, I'm going to let you take it away and run through it, and I will probably ask a few questions along the way.
Awesome. Thanks, Sean, for the introduction. So as Sean was saying, this first use case, we are trying to predict what product a customer will most likely purchase next. This is a really important use case, and it can really help bank managers and decision makers and credit unions and these organizations to create a better marketing strategy by understanding what product a customer will buy. They can, be able to sway customers with different proposals based on those products, and also in a customer satisfaction standpoint, we can make sure that we are providing customers with products that really are necessary for them and match their current needs. So just looking at the data set, we looked at about 25 columns and data elements that were all significant in predicting what product the customer will purchase. There was, over 2,500 rows, so the sample size was pretty significant, and we had a lot of customer data to make sure that we can create a model that captures those trends and patterns in predicting what product a customer will purchase next. So some of those data elements that we used to predict the product the customer will purchase was age, experience in professional settings, their income, their education, mortgage payment, and then their transaction in each of the past 4 quarters. And then the last 4 data elements are the individual products. So did an individual purchase a securities account? Did they purchase a CD account? online account or credit card account. For this use case, we're really going to look into if a customer will purchase a securities account or a credit card. So as Sean mentioned, that we use the Click Advanced Analytics Toolkit for this use case. With its connectivity with R, it has a lot of different machine learning and statistical analysis that we can take advantage of. So I'll first kind of show you the final product, where someone can go in and see the likelihood of customers buying different products based off the models we made with the Advanced Analytics Toolkit. We can kind of think of this as like the final cake and product that we want to emphasize. On top of that, after that, we'll go into some of the other capabilities of the Advanced Analytics Toolkits, in this case, a correlation matrix. And then after that, we'll just talk a little bit about how we use the different model capabilities of this extension to get to that final product. So with that, I'll go straight into the product analysis page. So this is a high-level dashboard where people can go in and see, high-level KPIs of the number of customers that would be high likelihood of getting a credit card, low likelihood of getting a credit card, and then high likelihood and low likelihood of getting a securities account. The table below that is each customer ID with the chance that they'll get a credit card, and then the probability associated with that credit card or with that chance. And then the same thing for securities account with low chance and high chance, and then the probability associated with that. After that, there's different fields that, a bank manager or decision maker can use when they're trying to, sell these products to these customers. But with ClickSense, adaptable and easy to use interface, it's really easy to kind of fine tune it and look really into the customers for different, chances for getting products. So if we want to look at the high chance customers for getting a securities account, we can sort it by, the customers with a high chance of getting a securities account. We can take a step further and filter it by the high chance customers. So now we have a table of all the customer IDs with a high chance of getting a securities account. If you want to take that a step further, we can even sort it by the probability. So now we have an ordered list of the high chance customers for getting a securities account by their probability. So this is a good way where decision makers can get a list of people that they can persuade to get this account, and that it actually does match their needs.
So Dom, as our bank clients decide that they want to put offers together to market to specific individuals, this is a great way to hone in on a specific list that you can market a specific offer to, in this case a securities account. You can export this right out of ClickSense, and it'll give you that list that you can then use in whatever marketing solutions you want. Cool.
So you can go and export it as a data, PDF, whatever you would like. And then kind of to what Sean's point, just by looking at some of these high chance customers, we can see for the top probabilities that a lot of these ages are above 50, are usually in the 60s. So that's just giving more insight into what kind of customers will most likely get a securities account, and it can be used in different marketing to, I guess, like kind of cold marketing, and then be able to understand what characteristics and stuff we should look into when we're marketing a securities account.
Perfect.
Cool. So with that, I'll go into a correlation matrix. So this is another capability of the Advanced Analytics Toolkit. It's more of a statistical analysis. So basically what this is showing is it's showing for all the fields the correlation value to other fields. So basically the correlation value is between -1 and 1, and a positive correlation value means that when the field increases in numeric value, so does the other field. So we can see with age, it was a really high positive correlation value. So when experience increases in value, so does age, which makes perfect sense. This is something that's really useful for exploratory analysis and being able to understand what fields you should use in a model. So when we're looking at the different products, we can see what values are highly correlated and might have a bigger impact on predicting whether someone will get a credit card. So we can see like credit balance had a really high correlation value, which again makes sense. So if someone has a higher credit balance, maybe they might need a credit card with a higher limit. Are they looking for a credit card with more rewards or perks? So yeah, that's just some of the ways you can use the correlation matrix. For us in this use case, when we looked at the correlation matrix, we really felt like all of these fields had somewhat of an impact on predicting these different products. So that's why for the model building process, we use all of these fields.
So let me kind of make sure I've summarized this a bit for you, Dom. So the correlation matrix can be used to throw a whole bunch of different fields from your data set together and then identify those higher correlation values, and then you can use those to craft the model that generated the table we looked at in the previous sheet, correct?
Yeah, definitely.
Perfect. Okay.
Awesome. And then after that, I'm going to kind of talk about like how we made the models. So with the Advanced Analytics Toolkit, there's a plethora of different models that you can use. For our case, we use a logistic regression for both the credit card and securities account. And basically what that does, it takes the different fields and it predicts 1, if someone will buy a credit card, or 0, if they don't buy a credit card. These estimates are the coefficient estimates, and these are the values that we plug in to get that probability, that percentage probability that will they actually get a credit card or not. On top of that, there's some more data science elements we can look into, such as the standard error, which looks into the volatility, and then the z-value and p-value, which really tests for the significance of these different fields.
But not to scare anyone away, Dom, if one of the folks on the webinar wanted to move ahead with this, this is something we bring to the project and they can leverage this kind of as it is. We would just simply change the fields that are brought in based on their data sets, and then the math would start to take care of itself, right?
Yep, so with the Advanced Analytics Toolkit, with its connectivity with R, it's basically a live connection. So you would, just select the model you'd want to use. You'd select the data fields, and obviously it can be tailored towards you. It doesn't have to be exactly these fields. And this model will go ahead and build out in a similar way.
Awesome.
And, just for like an evaluation standpoint, to the right, there's like a confusion matrix, which is just shown to see, how the model performs. So we can see for the number that we predicted 350 people would not get a credit card, and there was actually 350 that did not get a credit card in the data set. So that's 100% accuracy for that. And we predicted 150 would get a credit card, and 150 actually did get a credit card. So this accuracy is at 100%. So obviously we've seen that this model does a good job in predicting whether someone would get a credit card or not.
Excellent.
Awesome. And then for the securities account, we did the same sort of thing, except for this case, it's predicting if someone will get a securities account or not. We can see kind of with the evaluation, the accuracy is a little lower, but it's still very significant and does a great job with a 94.6% accuracy. With that, so that's basically how we built the model with the Advanced Analytics Toolkit. I'm just going to spend a few minutes discussing the Advanced Analytics integration with ClickSense. So basically in your ClickSense environment, with your different charts and tables, that data is sent to the ClickSense server through a hypercube. And then once your data is there, within your ClickSense server, you can install the free Advanced Analytic connector. And this will connect to R, Python, or really any machine learning languages you would like. So for the Advanced Analytics Toolkit, it connects to R. And when you drag and drop a model or a statistical analysis, it will send the data through this flow to R, conduct that analysis, and then go back and send that back to Click.
So I think the key thing here, Dom, is that once that connector's in place, you can have a live connection back out. So within ClickSense, a user could go make some changes, perhaps filter to a specific geography or just look at customers for a particular branch. And when they do that, it can rerun the model and update the data as it works right back through in the dashboard, right?
Yep. So like just take a look at the correlation matrix, for example. This is the correlation values for all of the data. If we want to look into a certain income group, we can filter for high income, and the correlation matrix will change based on this filter that we selected.
Okay.
So this is a totally live connection. And once this is integrated, and Panel Partner has integrated this in several of our clients, this will be live and you can go ahead and play around with the tool itself.
Cool.
Awesome. Cool. With that, we'll go on to our second use case.
Okay, so let's talk about the next scenario here. We're going to go in and we're going to predict customer churn. So again, just about every bank or credit union out there, just given the competitiveness in the marketplace, is always trying to figure out how to keep as many customers as possible, because we know it's so much more expensive to attract a new customer than it is to service an existing customer. So in this scenario, this demo, we're going to actually continue to use Click as the underlying foundation. But what we did is we went out and Pomerol Partners has a number of relationships out in the marketplace, and we partnered with a firm called Kunze Analytics. And we worked with Chris over there, and he put together a custom model for us that leveraged 10 different data mining models, consolidated it together, and built a customer churn predictive model that we can then consume or use right inside of ClickSense as a platform. Okay, and this is really important because that specific model that he put together for us, we can take that as a starting point and we can apply that to any bank or credit union and customize it to each bank or credit union's specific needs. Okay, which is great because everyone's got a slightly different mix of customers, you've got slightly different circumstances, and to be able to get that model set up to meet your specific needs is really important. So in this scenario, the client expertise level that's required, again, is very basic. Don't need a data scientist on staff. The software investment is also very basic. There's no significant extra components necessary to do this. And then the other thing I want to make clear is that to go build this custom customer churn model for your bank or credit union is really affordable. This is not something you have to go spend $1 million on with an IBM and have them build it for you. We can do these models for less than $10,000 per model. And then once it's built, you own it. We help you understand how to maintain it. And again, that model is feeding right into ClickSense to be able to do that predictive analysis on a regular, ongoing basis. And again, because of how it's put together, the services related to this is very light. Okay, so that's the kickoff. Dom, why don't you take this one away? I'll ask you a few more questions as we get into this, okay?
Awesome. So as Sean said, for this one, we're trying to predict the likelihood a customer will leave or stay at a bank. This is the same data set that we use in our previous use case, so the same number of rows. One of the advantages of using some of our technology partners is, especially in this case, they really specialize in making models in a variety of fields. And so Chris was able to go in there and look at all the data fields and select the 10 columns that were most significant for this use case. So for this use case, we're looking into income, number of complaints, credit card monthly average, mortgage payments, overall transactions, and etc. Along with that, Chris was also able to do a variety of data transformations, such as normalizing fields. This is really good in controlling the volatility in the models and the different fields. And so what Chris and our technology partner did was they used PMML code to make this model. And one of the benefits of working with Pomerol Partner is we specialize in integrating a variety of technologies and coding language back into Click. So once we were able to integrate that coding language back into Click, we were able to create basically a high-level overview of the churn risk, a more in-depth analysis of the churn risk based on income groups, and a risk calculator, which would be mainly used for ad hoc analysis. So with that, I'll go straight into the app itself. So this is basically the high-level overview page. It's showing the high-risk customers based on income group that will leave the bank. So we can see that there's 33 high-risk low-income customers, 112 high-risk medium-income customers, and 128 high-risk high-income customers. Below that, we have the different IDs for the customers, their risk, either low risk, high risk, and then the different fields that were significant in the model. So one of the things that when we're making this use case was, bank managers and these decision makers, they definitely have a busy schedule, and it's not really realistic to go out and pursue every single high risk customer. So income group is one of the ways that we can really prioritize the different customers and who we should try the hardest to keep. So if we want to, really save these 128 high risk, high income customers, we can go ahead and click on this KPI, and then it'll take you to the churn risk analysis page where it is filtered by the high income, high risk customers. We can see different KPIs such as the average income for this group, average age, their average mortgage, credit card spending, assets in the bank, and the average days since contact. We can go and see the number of clients by different fields, such as assets in the bank. So 10 would be the most assets, and 1 would be the lowest assets. So we can see that there's 10 clients or 17 clients that would have, the number 10 assets in the bank, with, again, the same table to the right, where it shows the ID and the different fields necessary. And so, as I said, this is the same data set that we used for the first use case. So another thing that we specialize in is being able to connect various data sets together to really paint the best picture and create actual insights from. So with these filters selected, we can go back to the product analysis page, and these filters are already created, and we can filter are sorted by the high risk or high chance for a credit card and the high chance for the securities account. So now for these 128 high risk, high income customers, we can see that 90 of them would most likely get a credit card and 11 of them would most likely get a securities account. So we just found a way that could potentially save 101 of these 128 customers by providing them and presenting them a proposal for products that most likely fit their need and will be most useful for them.
So let me go back for a second, Dom, and kind of make sure I'm helping the audience kind of understand exactly what we just went through. So if you go back to the sheet that we were looking at, the customer, the risk analysis here. So basically what we've done is we've honed in on a number of bank customers that, based on the model, again, that was put together off of this data set, we can see which of those high income customers are at risk of leaving the bank. Okay. So one use case we've seen clients use is they just simply take this list. Instead of ID, we can associate the customer name and their contact information, and we can export this list out. You could sort it by branch and actually send this out to a branch manager and say, hey, these are your high risk customers that are likely to leave the bank. We need to do something to keep them with the bank. But what you just did is you took it a step further. You said, we don't want to just contact them. Why don't we contact them and at the same time offer them something that they're most likely to actually respond to based on what we have in the data as well. So we're now not just saying, here's customers that we need to talk to, but here's something that we can talk to them about that has a high likelihood of achieving success or being converted, right?
Exactly. So it's more talking points, obviously, when you contact them, and just being able to persuade them with something that they potentially could like.
Cool. And then again, all of these columns are sortable. You can hone in, and or your marketing team or your marketing staff can go in and say, oh, well, I want to create offers that are more relevant to, let's just say folks in certain age demographics or folks that have different income profiles, et cetera. All of that's here because it happens to be in the data. Okay. So, Dom, I think one other thing for us to talk about for everyone as well is like different banks have different data sets, right? So
Yep.
in this scenario, um, we basically, we're not telling you exactly which data fields you have to bring to the party, so to speak. Um, we can take any sets of data and we can run it through the model and find the ones that are most statistically significant, right?
Yep, definitely. And then like especially with this case with the technology partner we worked with, obviously different banks will have different data they would want to look into, but like Kunze Analytics, we go to them with a different data set. They might be able to find different fields that are more significant, and maybe different trends and patterns. So yeah, every situation is a little different, and by no means is this, the final data set and the data elements that we need to look into.
Okay, awesome. Yeah, I think that's a really important point to note that, we can give guidance as to which data elements, um, from our experience, may have a high likelihood of predicting these different types of outcomes. But the reality is we don't always really know until we run it through the models and we see what the model tells us, which is the power of the data mining models that are available to all of us today. Yeah, this is fantastic.
Awesome. Cool. So with that, I'll go into the last part of this use case. And this is the churn risk calculator. So there will be a lot of times when there will be the need for ad hoc analysis, or you're meeting with a potential new client, so you don't have all their data stored, but you're getting that data as you talk to them. So this will allow you to, put in different values into the fields that were significant, and then it will spit out the likelihood that the customer will leave or stay and the risk associated with that. So we can see here, the only difference between the values in the fields is income, where it's 100 for the first calculator and 150 for the second calculator. And there's a huge difference with the risk associated with that.
Yeah, that $50,000 difference makes a massive difference in that likelihood, doesn't it?
Definitely. So if we look at education and we just change that to a 3, this is all live, we can see that the likelihood went down to a 20%. So a 3 just means that this customer had a postgraduate degree. So we can see that made a huge difference. So this can be used to get down data and kind of understand if a potential new client will stay or not. It will be good for kind of scenario analysis, comparing different scenarios and seeing the likelihood that they'll stay or leave. And so, yeah, there's a couple ways that this can make an impact in your organization.
Cool. And I think one last point to make then, and I'll kind of hammer on this point a little bit, is that, again, this is built individually, specifically to your specific bank based on your specific customer set. There are other vendors out there that, like particularly in the credit union space, that will try to aggregate credit union data from a whole host of them and then run it through a churn predictor. And in that case, your customer base might be very different. You might be more rural and you might be different than customers that are in a more of a metro area. Um, and so your model may not be as nearly as good of a fit. These models are done specific to your bank or your credit union with your customers, and can give you great insights on how to service that specific set of data. So this is great. Thank you, Dom. Cool.
Absolutely.
Are we ready to move on here?
I think we're ready for the third demo.
Okay, cool. This is your last one before we turn it over to Owen. So in the third demo today, we're going to go ahead and start to predict loan risk. Okay, and again, clearly it's important to see which, to predict which loans are most likely to fail. And the way we've worded it is to fail in achieving a positive return. Okay, some might be a little bit more pessimistic and say loan defaults, but we're going to word it this way. Again, in that theme of transparency, we've partnered with DataRobot, which is an industry-leading machine learning and artificial intelligence solution provider, to use DataRobot as a way to analyze a whole set of data to achieve this concept of predicting loan risk. So again, this demo, you're going to see how we leverage both Click and DataRobot together. You'll see how those two can be integrated. Again, in the spirit of transparency, we'll be very open and say the level of client expertise for this one is going to be more advanced. because we're really going to want to dig deeper into some of the data science behind it to make sure that it's using the right models. And you're going to really want to pay close attention to data quality as you go through this process as well. The software investment here is a bit more advanced because you are looking at an investment in Data Robot along with your investment in Click. And then again, on the professional services side, this is something that will require some more services to get both of these things set up and then make sure that they're properly integrated. However, not to bemoan the point, but Data Robot is an incredibly powerful platform that will run data through multiple models simultaneously and do a lot of the work to figure out which of those models are the best fit for your specific scenario. And you can use it for an immense variety of use cases. Okay. So a lot of power in Data Robot, and we're going to, Dom, I'll turn it over to you and show the audience here how this all works.
Awesome. Yep. So as Sean said, this use case, we're looking to predict the likelihood a customer will pay off a loan. So this is a new data set. We're looking at about 27 columns with, around 10,000 rows of data. So a little bit significantly bigger sample size. Some of the columns that we're looking at is who is their employee, the employee length, how long they've been there, income, payment plan, delinquencies, and etc. As Sean said, we'll be using Data Robot for this use case. There's a couple advantages using Data Robot. One is ability to use text data, so it's able to look into notes, the employee name, and actually incorporate that into the model, which there is some difficulties doing that in some in the other use cases. So for this use case, I'll kind of talk about the integration with Click and Data Robot. Click and Data Robot are partners, so there are extensions within the Click environment, such as the Click to Data Robot extension that will be able to send data from Click to Data Robot to create models. From there, I'll go a little bit more in depth on the Data Robot platform itself, how to make models, how to be able to view it, the different functionalities of the platforms. And then I'll talk about, bringing in the predictions from Data Robot and being able to visualize that in, a sufficient manner to be able to understand your results. So I'll first talk about the Click to Data Robot extension. This is a Click extension. It's free to use where you can select the fields you want to send to Data Robot. And then all you have to do is create a project name. So I'll call it loan project. And then you click create Data Robot project. So what it's doing now is it is preparing the data in your Click environment, getting it in the right format so it can be compatible with Data Robot's platform, and then securely sending that to Data Robot. So wait, might take a few seconds here to get it all the way sent to Data Robot. But so we can see now it's done. We can click the Open Data Robot project. And all we would have to do is select which, what we would like to predict, which would be is bad. That's just saying, is the loan bad or is it good? We can click on more advanced option, but we would just go and click Start. And this will go ahead and start making the different models. So we can see that Data Robot's, selecting the target features, it's creating the CV and holdout partitions, and is doing various other data science elements that's important in the model building, such as making different features and etc. We can go ahead and increase the number of workers to 10. So when they actually do start making models, they will be able to make more models at a time. And now we can see now it's done doing all of the data science steps. It's going ahead and making various models for this use case. For the sake of time, I am just going to show you a final project version of this. And so once your project is done building all your models, it will show all the different models you made and order it by various metrics that are important in data science. So like log loss is a very common metric used in classifier models like this to be able to understand if the model really performed well. We can hone in on individual models where we can see the blueprint used to make the model on how it actually got to the predictions. We can go into the understand section and see a feature impact where it says which categories and which data elements had the biggest impact on whether a loan was bad or good. So we can see the purpose category had a huge impact, with depth of income also, and annual income having a really important impact as well. We go to evaluate, we can see a lift chart. And basically what this does is this just helps us evaluate the model and make sure it's a good model. We can, they basically take the data and split it into 10 different subsets and basically showing how close the predicted values are to the actual values. So we can see that this model did a pretty good job in predicting the number of good loans and bad loans. You know, on top of that, there's a lot of different ways to be able to get predictions. You can simply put a CSV file in, and that will create a batch predictions, and you can download that. Or you can deploy a model API and use their REST API connection. And this is how we were able to get the predictions back into Click. So with that, Sean, if you don't have any other questions or you want me to explain anything more on Data Robot itself, I can kind of go into being able to visualize those predictions in Click.
Yeah, I think that's good. Yeah, why don't you go ahead and carry on that way.
Awesome. So when we bring back predictions from Data Robot, we are basically getting a percentage probability that the loan will be bad. So, with banks and credit unions obviously having different data, they might have different like risk associated with if a loan is good or bad. So we created a pretty adaptable and versatile app where someone can go in and select different thresholds for low risk, medium risk, and high risk. So if we want to say, a 30% probability that the loan is bad is a low risk, 30 to 70 is a medium risk, and above 70% is a high risk. Once those are set, we can go to a risk overview page, and it'll show you those different thresholds, as well as the risk associated for each of these loan IDs with the different categories, verification status, and fields important to predicting that risk. So this is a very versatile app, and you're able to kind of change the thresholds based on your specific needs and what you're looking for. From there, if you want to kind of dive deeper into the predictions itself, you can go to kind of like the risk analysis page where there's KPIs on the number of loan is bad predictions. So we can see there's 253 loan is bad predictions and around 9.75K good loan predictions. We can see that distribution for good loans and bad loans by different fields such as income range, our policy code, for example. So this is just a good way to understand where our predictions lie, where those distributions are, and kind of understanding where Data Robot is seeing there being more bad loan predictions. Now, once we get the real data, and one of the most important parts with data science models is tracking the accuracy and really evaluating the model. So once we get all of those, all the real data, we can see how the accuracy of the model was. So we can see it's at around 89.52%, which is a really good model. See the total transactions, and then we can see various other elements that are important in evaluating models, such as the true positive, which is basically of the number of bad loans we predicted, how many were actually bad loans, which were 250 in this case. True negatives, which is of how many we predicted to be a good loan, how many were actually good loans. And then false positives and false negatives, where false positives are for how many we predicted to be a bad loan, how many of them were actually good loans, and then for how many were actually good loans, how many were actually bad loans in real life. So this is just a good way in being able to evaluate your model. You're able to see that in more visual form, where the red bar is showing the actual number of bad loans and the blue circle is showing the bad predictions, and vice versa on the right side. The blue bar is showing the actual good loans and the red dot circle is showing the good predictions.
And this is a good example where when we talk about gaining a little bit more depth of understanding by the client can be important in these scenarios, because it's important for you if these models are going to be running on a regular basis, for someone on your staff to really understand what this means. Again, you don't have to be a full-on data scientist, but it's important that the client has some foundational understanding of these principles, right?
Yep, definitely. And on top of that, like as I said, this is a good way to evaluate your model. So we see that it does pretty well with 89.52% accuracy, but we see that there's a lot of false negatives. So machine learning being an iterative process, and especially if you do go down the data robot route or track, you can continue to fine tune your models and continue to make it better through adding more features, doing various steps in your data preparations that could hopefully decrease this value.
Excellent.
Awesome.
Okay. Do you have any other pieces to highlight here, or are we ready to move on?
I think we're ready to move on to the last demo.
Okay. All right, so we're going to switch gears just a little bit here. First and foremost, we're going to switch presenters. So Owen Bott's going to take over now. So if you guys need to do any, do you need me to switch that behind the scenes, Owen, or are you able to take presentation here?
All set. I'll just present from Dominic's screen.
Okay, cool. And then, all right, so let me set the stage for this last demo. So this is all about figuring out where might be a good place to put your next retail branch location. And this is something that's come up with a number of companies, even outside of the banking space. And with Click as a platform, they have some out-of-the-box functionality called Click Geo-Analytics, which enables us to bring in data from all these different sources, integrate it together, and then power up different maps to let you look at your data in a geospatial method, and use that to identify perhaps gaps in coverages where a retail branch might make good sense. So there's a couple things going on here. First of all, we want you to know that we're bringing in some third-party data as part of this demonstration. We have a partnership with a number of data providers. In this case, Roof Strategic Solutions has provided us persona data about demographic. These are individual personas made by geographic area, and you'll see some examples of how they create these personas to help you understand the customer makeup in different geographies. So as we step through it, you'll see, again, the level of client expertise to execute this type of a ClickSense dashboard is still pretty basic. And the software investment is also pretty basic because GeoAnalytics is included at no additional cost in the cost of ClickSense Enterprise. Again, here there is some third-party data services that are included. These are usually done through a subscription because you kind of want them to update on a regular basis. And that cost is going to vary, as you might imagine, by the breadth and depth of the data that you want to procure. The professional services, again, in the spirit of transparency, there's a little bit more work that's involved in this just to make sure that you're setting everything up in your data model and that you're getting the geoanalytics component spun up the right way to do what it is you want to do. All right, so that pretty much sets the table. I'm going to turn it over to you, Owen, and take it away.
Thank you, Sean. So decision makers in retail environments have more data at their disposal now more than ever. And while this abundance of data brings with it a new set of challenges, the driving principle at the core remains the same. Understand the markets you operate in and know your customers. So here we're using interactive maps to build a powerful visualization of our markets and our customers. As you can see, in a head-to-head comparison of Wells Fargo and Bank of America, it's a closely fought battle in the southeast region of Miami. I'm sorry, of Florida. If I were to zoom in a little bit more towards Miami, I can see exactly what the market share is looking like between these two branches, between these two companies, Wells Fargo and Bank of America, who's winning the branch deposits. Or if I wanted to, I can switch it over to the number of branches over the course of a few years as well. And as you can see, Wells Fargo is increasing the number of branches, while Bank of America has been decreasing. And I can also look at the average deposits per branch, which Bank of America is slightly below the average deposit compared to Wells Fargo. Now, if I were to do the same sort of analysis, but I wanted to hone in on a different area, let's say the Fort Lauderdale area. I can do the same sort of analysis and see that Wells Fargo is winning the deposit growth and branch growth, while Bank of America is winning the race on deposits and number of branches. But who is actually driving, and what is driving these factors? The true story starts to unfold as we visualize the branch locations and their relationship to each other, their market reach, based on a variety of factors. And in this case, we looked at drive time. So here we're examining branch locations in the Fort Lauderdale area and their associated drive times. So each region here determines and defines the reach of a certain retail location. So as you can see, I have different variables turned on. If I were to turn a few of these off. So these are some different retail locations, and imagine each one there's a center point, and this is the reach that that retail location can extend within a 5-minute drive. If I wanted, I can look at other factors as well. So if I would turn off the 5-minute, I can turn on the 15-minute or 10-minute drive, which seems pretty reasonable. But with this analysis, we can see obvious territorial holes and gaps. We can see potential territorial overlap between multiple branches of the same institution. And by visualizing territorial coverage and complementing this with branch performance data, we have a very powerful tool to analyze the effectiveness of our branch distributions. In a competitive environment, the location of other market players is pivotal. Where are we lacking? What competitors are monopolizing? And where can we rationalize fighting for a given territory? Picking the right battles and understanding the customers you're competing for is extremely important. In the densely populated area of Fort Lauderdale, we can see that both Bank of America and Wells Fargo are competing for the customers in this area. But what type of customers live in this area? We can zoom in. And if we were to select a certain area, Harbor Heights, is this branch location justified? You can jump over and see who actually is there. What type of demographics make up this area? Individuals in this area are often characterized with the persona career couples. These are professional couples with no children, career focused, and a keen eye in investments, real estate, and early retirement. The residents of this area have a 90% participation rate in the financial markets, an average home value of nearly $800,000. With a high propensity to both lend and invest, this branch location is justified in its market coverage. We can also see where we're
and Owen, just to make a point, that demographic data that we just saw there that defined that persona, that's the information that we were able to source and bring in to Click from a third party. So just as an example, this can be very different than the core systems that you might be used to using with your bank. Click lets us integrate all of this data together, and you're not reliant on having to put it all into your core system to get this kind of analysis capability.
Yeah, absolutely. Great point, Sean. This is, like we mentioned earlier, one of the benefits of incorporating third-party data into your own data. It really allows you to understand and see past what you're controlling, what you're obtaining, and allows you to consider other factors as well in your analysis. So as we can see, Fort Lauderdale is a very competitive area for these two banks. But now, what areas are we potentially missing, or these two banks are potentially missing? For example, this plantation area. What type of persona live there? Could a retail location be justified if a Wells Fargo or a Bank of America were to open up a retail location there? So if zooming in on the demographics of that area, we can see that this plantation area, with the demographics suggesting, is that there's a high portion of retirees living in this area with a 91% ownership, with a 91% home ownership. And with a 70% likelihood of investing, this area could potentially be being overlooked without a retail location within a 10-minute drive. Now, if we were to consider other factors, a 15-minute drive or anything along those lines, we can also do more analysis on those lines as well.
So a real key here, Owen, is that by looking at this information, this data on a map, and again, we're able to get FDIC deposit information. That's another data set that was brought into this to help identify those deposits. And by doing that, we can literally look at the map and see holes in the map where, both Bank of America and Wells Fargo are kind of missing their mark, and then analyze to see if that's a good place to put a competitive branch, right?
Yeah, absolutely. I mean, we can get data from the FDIC regarding that, branch deposits. We can also look at average income per area, population as well. There's a ton of different factors or metrics we can look at that would provide different insights and analysis based off in determining where our retail locations are being most effective and efficient as well.
Cool.
And one last point I just want to hone in on is that by using these interactive maps and charts alongside with these third-party demographic data, in combination with your own data, you get a better understanding of the markets you can operate in and the customers you're catering to really become a more efficient and lean company altogether.
Excellent. All right. Well, we're coming up on the top of the hour, and there was one key question that I really wanted to make sure we addressed right before we end all of this, and that was, why would I use Click instead of just my core system? My core system provider says they can provide, for example, customer churn data or customer churn analysis. And the answer I wanted to make sure everyone understood is that with Click as a platform, we can integrate data from all kinds of different sources. Most core platforms require you to build complex integrations if you want to add any additional data into them, or you're kind of beholden to whatever the core platform vendor is building for you. Click allows you to customize your analyses specific to your needs, pull in marketing data from a marketing system, pull in sales data or sales opportunity data from a CRM system like Salesforce. We can do all of that and bring that all together in Click as a platform. So that's a real key differentiator between Click and the core systems that are out there. All right, so with that, we're up at the top of the hour. I want to thank Dom and Owen for taking us through the different demonstrations today. You guys did an awesome job. I think we made it a lot clearer. Obviously, we want to thank Click for the contributions that they've made to all this, and to emphasize just how flexible we can use Click as a platform to make this all happen. And then finally, I want to thank a couple of our partners that have helped us out with this. Kunze Analytics, Chris and his team, and Data Robot for the capabilities that they offer up through their platform as well. So with that, if there's any other follow-up or questions, you've got my contact information there on the screen. And with that, I want to just say thank you so much for participating in this, and we hope to get a chance to talk with you very soon. Thanks, everyone, and have a great rest of your day.